Hello everyone. Today we are going to solve find minimum in rotated sorted array. And yeah, this question is seventh in the array section of 75 questions. So yeah, let's start diving deep. Let's jump into the question. So yeah, I usually follow these 8 steps for each question so that it's just a way that I'd like to explain or go through every question in an interview so that the interviewer is more satisfied. And if I have to pick one step out of this, which I think is the most important one, is this one. I would say this is also important because if you don't understand the question correctly, then sometime might be the issue. But if I have to pick one, because sometimes if you know how to find all the correct test cases, edge cases, then questions can be clarified through those edge cases, and then you can say, oh, okay, this edge case is tricky or things like that. So this is the most important part, I would say. But yeah, if we go down this way, this is always good. So okay, let me start. So first step I do is read and understand the question. So the question says find minimum in rotated sorted array. So the big part here that I'm thinking is like this array is always, not always, array is sorted. Okay, so let's go dive deep. Suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, array might become that's not correctly showing in the image, but 1, 2, 0, or 7 times. Okay. Notice that rotating an array. Alright. Sorry. Yeah. Rotating an array one time results in the array a(n minus 1. Okay, sounds good. So basically, what they are trying to tell us is if an array looks like 0, 1, 2, 3, if we rotate this array 1 times, it will become 3, 0, 1, 2. From this to this. Okay, that makes sense. Now, question says, given the sorted array, nums of unique elements, return the minimum element of this array. You must write in logarithmic and time. Okay, sounds good. So, basically what the question is trying to tell us is that the array will always be sorted, but it's, sorry, just a second. But it's rotated. So, okay, sounds good. And they want us to do it in logarithmic and time. So once I've clarified the question and understood it, next thing I like to do is input and output. So if we can see here, input here is a vector of int, and also if you see, they mentioned that there are no unique elements, or unique, and output is just going to be the minimum value. So if you think about, yeah, okay, we'll discuss that later. But once we've done these 3 steps, next is writing test cases and edge cases. So let's look into that. And here they're saying that if n is num's length, oh, sorry. Yeah. If n is the num's length, then n is always greater than 1 and less than 5,000 and stuff like this. So that means that never an array as an input, this will never be passed. But anything more than 0 can be passed. So it can be 1, it can be 1, 2, 3, it can be 2, 1, 3. Actually, sorry, my bad. It can be 3, 1, 2, and it can be anything more than 3 tools. So like, let's say 5, 6, 1, 2, 3, 4, and it can just keep increasing. So there are many inputs. And let's see, unique. Okay, sorted return. Okay, now that we understood the question and we know that the question is asking us to solve this in logarithmic and time. If we want to do it first brute force in big O of n, what we can do is just we can iterate through the vector. Let's say the question is 4, 5, 11, 3, 13, 15, let's say. if we want to do in big of n time, we can just iterate through vector and keep the normal value min in style, starting with int min, and then we keep updating. So it will start with 11, and then we go forward, stay 11 for 11, 17, 11, and we'll return 11. But that's big of n. Logarithmic n, whenever anything, yeah. So let's see, the brute force is done. Let's see efficient solution. So whenever we hear these two combinations, sorted array, we should always try to see if binary search can be applied. So if you think about it, let's take an example here now. So let's say array can be 1, 2, 3, 4, 5. Array can be 1, 2, 3, 4, 5. Array can be 1, 2, 3, 4, 5. Or array can be 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5. So the minimum value in the array can be either at the beginning, in the middle, at the end, or somewhere in the middle. So if you think about it, if we look at this array, what does binary search do? Let me talk about binary search first. Binary search is, let me erase this and discuss about binary search here. Binary search always goes towards the number we want to find. So let's say if it's 1, 2, 3, 4, 5, this is the code for binary, while L is less than equals to R, where L starts with 0, R starts with nums.size. Let's say this is the thing. Then at each level we calculate mid, which is L plus R minus L by 2. And then if we say, let's say we are trying to find a target, if target is greater than nums of mid, that means it will lie in the next first half, so we'll do L plus plus, else R minus minus. And in this any case, if we can do like if target is equals to nums mid, return I. So this is basically a code where we return the index of some target that we want to find in a sorted array. So if you see, we in this code we always go like, we come here and then we decide which direction to go, which is because it's sorted. So yeah, now how can we use binary search in this question where we want to find the minimum in the sorted array? So if we see, these are the 5 possible solutions. So every time we divide the array, let's say in 2 parts, we can always say that one part will be always sorted and one will not be. So if you see, one part is sorted, this one is not. 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 So that's one thing that's going to happen if it's rotated, that always one part will always be sorted of the array. But in this case, we want to find a minimum one. So yeah, I'm thinking. So what we can do here is, that we calculate the mid. At each iteration, we'll calculate the mid and we'll see which one is sorted. Actually, we don't even need to do that. I'm trying to think. One, two, three, four, 5. Now we want the minimum. So even if we keep iterating towards the minimum, Yeah. So one thing through this, if we look, the minimum will always reside in the unsorted array. So if you see this one, minimum resides this one, minimum resides this one, minimum resides this one, minimum resides this one. So every iteration we calculate mid and move the pointer towards so array which is not sorted. Then we can just keep going through and keep checking. So what I'm proposing here is when L equals to 0, R equals to, let's say, nums dot size. So we've got the pattern here that every time we, like in all the possible cases, uh, the number will always lie in the unsorted part. So what I'm saying is like this 0, then we can do while L less than equals to R. Now what I'm saying here is for mid equals to, let's say, L plus R minus L by 2. Then here I'm going to do 3 big of 1 checks. One is, and uh, I also want to take a global min, which will be int min. Actually, int max. So now what I'm going to do here is at every iteration, global min will be the minimum value of nums L, nums R, nums mid, or global min. And then once we set this up, then we want to move towards the array which is not sorted. So what we're going to do is if nums L, nums mid is smaller than nums R, that means this array is sorted. So we want to move R minus minus. Else, that means left part is sorted. So we'll do L plus plus. Now as you see, and then at the end, we're going to return mid. Yeah, this should work. So let me quickly code this for you guys and see. And if you see, this is binary search code. So this will be big log of n because we'll always be only traversing half of the array. So let me code this for you guys. We're gonna start with int L will be 0. Sorry. Nums dot size minus 1. One more thing that I'm missing here is int global min is equals to max, and what while L is less than equals to R. Now what I'm gonna do here is, first thing we are gonna do is calculate mid, which is L plus R minus L by 2. Once that's done, we'll check let's just say this: if global min is less than nums L, now we can do the similar thing for all the if global min is less than nums mid R, and if not, once this is calculated, what we would like to do is say if nums mid is less than nums R. Nums mid is less than nums R. That means right one is sorted. So we want to move to R equals to mid minus 1. Else, and at the end we're gonna return yeah. So this is what the code will look like every time first of all, if it is 0, we'll go in, we'll calculate mid, which will turn out to be 0. Global min will be set. Actually, sorry, global min, then this will be like this. Global min will be bigger than numcell, then we'll send go edit that, and same thing goes. Then we'll be like nums mid greater than nums are. Yeah, you can see an accepted solution. Yeah, we calculate mid, that is that. If nums r is greater than nums mid, that is true. Let's run the code, accept it, let's submit the code. Alright, 0ms. Took some memory though. Let's see how we can improve. Hmm. 8.3500. Yeah, the memory also improved, but time decreased. But yeah, that's the solution for this question. The important part was here was tracking a pattern in the arrays. But yeah, once we did that, the question became easy. So thank you, everyone. I would suggest you to write down more test cases and try to run this algorithm on those. But yeah, please let me know if you have any questions and comments. Thank you.